Hello everyone, my name is Gražvydas Kazakaitis, and today I would like to present to you a presentation on smart hardware. So today's lecture will cover the following topics: brief history of furniture hardware and relevant terminology, typical problems faced by designers, how Woodwork for Inventor can help, a small example to illustrate how our system works, and where to find additional information. Let's take a couple of minutes of your attention, and I will quickly provide an overview of the history of furniture hardware and the terms and types that are used. I understand that some of you have been in the furniture business for a long time, but not everyone here may be familiar with it. So what exactly is furniture hardware and what does it do? Furniture hardware refers to components that secure, fit, and assemble individual pieces to create a functional and durable piece of furniture. Typical examples of furniture hardware are various runners for drawers, wardrobe fittings, handles and knobs, hinges and brackets, various kitchen drawers and fittings, wood moldings, and many miscellaneous, including tabs, coat hooks, towel rails, and many others. So the history of hardware for furniture is a tale of innovation and adaptation, closely intertwined with the evolution of furniture design and manufacturing techniques. Here is a brief overview. Ancient beginnings. Hardware for furniture can be traced back to ancient civilizations such as Egypt, Greece, and Rome. In these early times, furniture hardware was often crafted from materials like bronze, iron, and wood. Simple hinges, locks, and decorative fittings were used to enhance both the functionality and the aesthetic appeal of furniture pieces. During the Middle Ages, skilled artisans produced intricate metalwork to adorn furniture in castles and churches and wealthy households across Europe. This period saw the emergence of ornate handles, hinges often featuring elaborate designs inspired by religious motifs and nature. The Renaissance brought a renewed interest in classical art and design, influencing furniture hardware with an emphasis on symmetry, proportion, and decorative detail. Brass became more popular material for hardware, favored for its moldability and ability to be finally crafted into intricate shapes. The advent of Industrial Revolution in 18th and 19th centuries revolutionized the production of the furniture and its hardware. Mass production techniques enabled the widespread availability of standardized hardware components such as drawer pulls, knobs, and locks, making furniture more affordable and accessible to a broader population. The 20th century saw the introduction of new materials like plastic, aluminum, and stainless steel into furniture hardware manufacturing. These materials offered advantages such as durability, corrosion resistance, and versatility in design. Modern furniture hardware often features sleek, minimalistic designs that complement contemporary interior styles. The recent decades, advances in technology have further transformed the production and design of furniture hardware. CAD software allows for precise customization and prototyping of hardware components, while innovations in material science continue to expand the possibilities for creative expression in furniture design. And today here is growing emphasis on sustainability in furniture manufacturing, driving the development of eco-friendly materials and production processes for hardware. Additionally, designers are exploring innovative ways to integrate smart technology into furniture hardware, offering features such as wireless charging capabilities or integrated LED lighting. So throughout history, furniture hardware has evolved in response to changing aesthetic preferences, technological advancements, and societal needs, playing a crucial role in both the form and function of furniture design. So now let's delve deeper into the typical problems designers face and how Woodwork for Inventor can provide solutions. Here is a quick brief summary of key points where furniture hardware components are commonly used. Drawer slides come in various types such as ball bearing slides, undermount slides, and side mount slides. Hinges allow doors to swing and open and close smoothly and come into different configurations like body hinges, concealed hinges, and piano hinges. Handles and knobs not only serve a functional purpose, but also contribute to the aesthetics of the furniture piece. Handles and knobs come in various styles, materials, and finishes to complement different design themes. Locks and latches come in different types, including cam locks, mortise locks, and magnetic catches, and are essential for safeguarding valuable items or sensitive documents. Casters and glides are used to provide mobility and stability to furniture pieces such as chairs, tables, and cabinets. Shelf supports or brackets come in various designs, including adjustable shelf supports, hidden shelf supports, and decorative shelf brackets, and provide structural support for storing items. Table hardware includes components such as legs, slides, and table fasteners. Bed hardware includes components such as bed frames, rails, bed connectors, and bed fittings used to assemble and support beds. Finally, decorative hardware. Decorative hardware elements such as trim, rosettes, and embellishments and add visual interest and decorative flair to the furniture pieces. So now let's focus on the main challenges for designers when using hardware components in their design. Complexity of hardware geometry and furniture hardware components such as hinges, drawers, and slides can have intricate geometries that are challenging to model accurately in CAD software. Designers may need to invest extra time in creating or finding detailed models that capture the nuances of hardware. Compatibility verification. Ensuring that hardware components are compatible with the furniture design can be a challenge. Designers need to accurately model the dimensions and specifications of both the furniture piece and the hardware components to avoid issues during assembly or installation. Design models should be good enough and adopt the design changes without any issues, allowing designers to reuse and adapt the typical designs with several parameter change only. Assembly simulation. CAD software may lack advanced simulation capabilities for testing the assembly of furniture hardware components. Designers may need to rely on manual methods or separate simulation software to validate the fit, function, and movement of hardware components within the furniture design. Integration with manufacturing process. CAD designs need to seamlessly integrate with manufacturing processes, including CNC machining, 3D printing, and assembly. Designers must ensure that the CAD models accurately represent the manufacturing requirements for incorporating hardware components into the furniture design. Collaboration among designers, engineers, and manufacturers can be hindered by the limitations in CAD software for sharing and reviewing designs with embedded hardware components. Designers may need to adopt collaborative CAD tools or employ alternative methods for communicating design intent effectively. Version control and revisions. So managing versions and revisions of CAD designs that include furniture hardware components can be complex. Designers must implement robust version control practices to track changes, revisions, and iterations of the design throughout the development process. And finally, cost estimation. CAD software may lack built-in tools for accurately estimating the cost of the furniture hardware components and their integration into the overall design. Designers may need to manually calculate or rely on external resources to estimate material costs, labor costs, and assembly expenses associated with hardware integration. So, where can Woodwork for Inventor be used and what problems can we help solve? So, first of all, simple and easy insertion procedure. Woodwork for Inventor allows for the quick insertion of the hardware components and smart components with just a few clicks. Moreover, it utilizes a simplified wizard for insertion. Automatic decisions. Our furniture library components can come with built-in iLogic code that adapts components to the necessary situation. This enables automation of processes and significantly reduces time consumption. Reduction of errors. Thanks to automatic decisions and iLogic usage, we can decrease the number of errors, especially when designers modify the geometry or shape of the final design. Tracking updates models accordingly to geometry changes. Woodruff for Inventor analyzes connection geometry and participating boards. Any changes in that area allow us to implement updates if needed and adapt components to the final design. We do not only provide our own components with installation, but also offer the option to create custom components using our samples. This allows Woodwork for Inventor to be versatile and integrated into customers' work environments as much as possible. Our components provide all necessary information in a bill of materials. Furthermore, we have implemented many trips and ticks that make it easy to modify BOM components using iLogic, iParts, and iAssemblies for such manipulations. Last but not least, we provide API mechanisms for various situations, including hardware renaming tools via API.